Welcome to your Sunday afternoon chemistry lesson. At least I'm recording this on a Sunday. This video presentation will help you classify matter. Remember that matter is defined as anything that takes up space and has mass. So we have to classify matter into different components so we can more easily talk about all the different types of matter we know about in the universe. So after this lesson, you should be able to know that all matter is made up of atoms and molecules, and you should be able to classify different types of matter in terms of their arrangement of atoms and molecules. This particular diagram down below here, you'll notice that it has matter broken down into a bunch of different categories. You do not have to copy this down right now because we're going to just focus on this right-hand side here, and we'll talk about that a little bit later on. Definition. Atom. An atom is the smallest part of all matter. Now, of course, we could think about what makes up an atom of protons, neutrons, and electrons, but we're going to put that aside for the time being. So let's just consider here that the atom is defined as the smallest part of all matter, and that we know that there are only 118 different types of atoms that we know of in 2020. All of the atoms will have the same number of protons in the nucleus. Now, where can you find these different types of atoms? You can go ahead and look at a periodic table, and you're going to see a link at the bottom of this assignment for a really nice online periodic table that I would recommend bookmarking to your computer. Also note here that atoms are going to be modeled by different colored circles. New definition, molecules. Molecule is defined as two or more atoms that are bonded together. So A and B here have just turned into a blue circle and an orange circle. And notice here that the blue circle and the orange circle are overlapping each other. In this video, I'm going to use overlapping different colored atoms, or maybe same colored atoms, to represent molecules. So in molecules, two or more atoms that are bonded together. So how do atoms and molecules mix together to make matter? So now we're going to start to take the whole big category of matter and break it into two parts. Part number one is pure substances. And a pure substance is defined as matter that is made up of only one type of atom or one type of molecule. Here's a model for you. Notice this first type of pure substance here is just made of one type of atom. So this is the model for pure substance made up of just atoms. Here is a sample of a pure substance made up of just one type of molecule, where you've got your orange and blue overlapping molecules. So this is also a model of a pure substance, just one type of molecule. So let's name these two different types of pure substances. If I got a sample of a pure substance that is made up of just atoms, we're going to call that sample an element. So an element is anything that is made up of just one type of atom. If I've got a sample of a pure substance that is just made up of one type of molecule, I call that a compound. So a compound is a sample of a pure substance that is made up of just one type of molecule. So here's some common examples of elements and compounds. Here's some common elements. Here's gold. The symbol for gold, if you look on a periodic table, is AU. And every bar of gold here is only made up of one type of atom, and that is a bunch of gold atoms. So that is considered an element. Here's sodium. Every single silver block in here is made up of just one type of atom. It's made up of bazillions and bazillions of sodium atoms. Sodium has your symbol Na from your periodic table. So this is also considered an element. Here's some common compounds. Now notice the difference here. Sodium chloride is table salt. It is made up of one type of molecule, which is consistent of one sodium and one chlorine bonded together. Notice that sodium chloride and sodium are two different types of pure substances. One is an element, one is a compound. Carbon dioxide, another type of compound. Every molecule of carbon dioxide consists of one carbon and two oxygens. That's where the subscript 2 comes from. And this is a picture of our current greenhouse or carbon dioxide levels in our atmosphere. And carbon dioxide is the predominant greenhouse gas that is leading towards climate change. That's why I threw that graphic in there. So here's a thinking question. I'd like you to pause this video and I want you to answer the following. I have a model here with a bunch of molecules, but each molecule has the overlapping orange circles. Do you believe that this is a compound or do you think it's an element? And please describe why you think so. When you've written down your answer, unpause the video and check it. Hopefully you've made an answer to this, and let's check it against mine. This is going to be considered an element even though it's made up of a whole bunch of molecules. And that's because every single molecule here consists of the same type of atom. In fact, these types of molecules are special. They're called diatomics, where di means two, atomic means atoms, diatomic atoms. And so examples that could look like this are hydrogen and nitrogen, fluorine, oxygen, iodine, chlorine, bromine. All of these are still considered elements, even though they are made up of molecules. Now we're going to move on to the other side of the tree diagram. We already talked about pure substances. Now we're going to talk about mixtures. So here's one type of mixture where you've got two different types of atoms. They are not overlapping, but all these atoms are pretty much the same size. Here's another type. Notice that you got two different types of atoms here, but these atoms are considerably different sizes. So these are models of two different types of mixtures. The first type of mixture is called a homogeneous mixture. The prefix homo means same. So if I've got a sample of a pure substance that is made up of a bunch of different types of either atoms or molecules, those atoms and molecules are almost the same size as each other. So when you mix them together, you can't see the difference between the two. That means that you've got a homogeneous mixture. So it's when you look at a mixture and you can't see the different components because all the particles are almost the same size of each other. Now here's a heterogeneous mixture. If I was to look at this, all the particles are all different sizes. So I can see the different components. Since I can see the different components, I can see the different parts of the mixture, and that's why it's called heterogeneous. The prefix hetero means different. All those atoms are different sizes. Let's look at some common examples of homogeneous and heterogeneous mixtures. Here are some good heterogeneous mixtures. Salads. Salads are great examples of heterogeneous mixtures because you can see the difference between the crackers and the lettuce and the tomato and the cucumber, and I think those are olives. All of those are made of different types of mixtures themselves and different pure substances, and I can see all the different components. So a salad is definitely a heterogeneous mixture. How about ice cubes in a soda? So not only that, you can see the difference between the ice cubes and the soda, but you can also see the carbon dioxide gas inside of the soda too. That's where the bubbles come up in your soda. So all the components here you can see, therefore it's a heterogeneous mixture. Here's some common homogeneous mixtures. How about coffee? Coffee, you've got your coffee beans that have been filtered with hot water. You might have cream in there. You might have sugar that's dissolved in there. You can't see those components if you stir really well. So that sample of coffee is going to be a homogeneous mixture. Air. The air we breathe is a homogeneous mixture. Our air is about 70% nitrogen, about 20% oxygen, and about 10% other stuff. And we can't see those different components. Because we can't see those different components, all of those particles are mixed together, and therefore it's a homogeneous mixture. And trace back to our alchemy video that we did a couple of days ago. There's the alchemist symbol for air. So let's put this tree diagram all into one diagram here. So here's your tree diagram that breaks apart the different types of matter. I would pause your video and write this down definitely here. So here's matter, anything that takes up space and has mass. It can be classified into two pieces of a pure substance and a mixture. Pure substances can be broken down into compounds, which is one type of molecule, or elements, which are one type of atom. And mixtures can be broken down into homogeneous mixtures and heterogeneous mixtures. Heterogeneous mixtures are where you can see the different components. Homogeneous mixtures are where you cannot see the different components. On the next slide here, what you're going to see are a bunch of different types of matter. And I want you to take the time and see if you can classify these into pure substances, mixtures, and then one more step into if it's a mixture, homogeneous or heterogeneous, or if it's a pure substance, a compound, or an element. So attempt to identify these as elements, compounds, heterogeneous mixtures, homogeneous mixtures. You might be able to think some of these out, or you might want to do some research. Maybe this one down here, you might want to do a little bit of research of what makes up steel. So pause the video at this point and make your best guesses about what types of matter these are.